from the first lens. Determine by calculation the position of the final image. What is the name given to optical instrument with this arrangement of lenses? Solution. F1 is equals to 30 cm, F2 is equals to 5 cm, and U2 is equals to 34 minus 30, which is equals to 4 cm. From 1 over U2 plus 1 over V2 is equals to 1 over F2. Substituting the value, you have 1 over 4 plus 1 over V2 is equals to 1 over 5. 1 over V2 is equals to 1 over 5 minus 1 over 4, which is equals to 1 over 20. V is equals to 20 cm. Final image is from 14 cm from the first lens or 20 cm from the second lens. The type of instrument is astronomical telescope. Chapter 4, Fields. We'll be dealing with gravitational fields, electrical field, magnetic field, electromagnetic field, simple AC circuits. Concepts of field. Any region in a space under the influence of some physical agency such as gravitation, electricity, and magnetism is known as field. Examples of field include the gravitational, magnetic, electric, and nuclear fields. Gravitational field. Gravitation is the force of attraction exerted by a body on all other bodies in the universe. Thus, a gravitational force exists between a body and all other bodies around it. Newton's law of universal gravitation. Newton's law of universal gravitation states that the force of attraction between two given particles is inversely proportional to their distance apart. From Newton's law, it follows that the force of attraction F between two particles of mass m and capital M respectively at a distance r apart is given by F is proportional to small m times capital M all over r squared. Therefore, F is equal to capital G, big capital M, and small m all over r squared, where G is proportional constant known as gravitational constant. Relationship between force of gravity, mass, and acceleration due to gravity. Force capital F is equals to mass m times acceleration due to gravity. Therefore, Fg is equals to m small m times small g, or small g is equals to capital F over small m, which is equals to capital G times capital M all over r squared. But capital Fg is equals to capital G times capital M times small m all over r squared, where capital M is the mass of the earth, G is the gravitational constant, M is the mass of the object, and r is the earth's radius. Gravitational potential and escape velocity. Gravitational potential. The potential due to gravitational field of the earth is defined as numerically equal to the work done in taking a unit mass from infinity to that point. On the surface of the earth, we can show that the gravitational potential is given by capital V equals to capital G times capital M all over R, where capital M is the mass of the earth, assuming to be concentrated at the center of radius R. Escape velocity. The escape velocity Vg is given by Vg equals to square root of 2 times capital G times capital M all over R, which equals to square root of in bracket 2GR, where G is equals to capital M times capital G all over R squared. Example 1. If a photon mass is 1.67 times 10 raised to power minus 27 kg, and electron mass is 9.11 times 10 raised to power minus 31 kg, and the radius of hydrogen atom is 0.05 times 10 raised to power 10 meters, calculate the gravitational attraction between the charges. Solution. F gravity is equals to capital G times capital MP times small me all over R squared. Substituting the values, we have the G constant to be 6.67 times 10 raised to power 11 times the capital M is 1.67 times 10 raised to power minus 27 times the small m is 9.911 times 10 raised to power minus 31 all over the radius, which is in bracket 0.53 times 10 raised to power 10 squared, which will now give us 3.6 times 10 raised to power minus 42 Newton. Example 2. If the mass of the Earth, capital M of radius 6.4 times 10 raised to power 6 meter is 6.0 times 10 raised to power 24 kg, calculate the force per unit mass on the Earth's surface, taking capital G equals to 6.7 times 10 raised to power 11 meters square per kilogram per seconds. Solution. The force per unit mass on the Earth's surface is given by G equals to capital G times capital M all over R squared, where G is the acceleration. Small g is now equals to 6.7 times 10 raised to power minus 11 times 6.0 times 10 raised to power 24 all over, in brackets 6.4 times 10 raised to power 6 squared, which is equals to 9.81 meters per second squared. Example 3. If the radius r of the Earth is 6.4 times 10 raised to power 6 meters, and the acceleration g due to gravity is 9.8 meters per second squared, calculate the escape velocity of a rocket from the Earth's gravitational field. Solution. Velocity of escape VE is equal to square root of 2GR. VE, substituting the values, we now have square root of 2 times 9.8 times 10 times 6.4 times 10 raised to power 6, which will give us 11 times 10 raised to power 3 meters per second, or 11 kilometers per second approximately. Example 4. Calculate the gravitational attraction between two spheres are apart and whose masses are 16 kg and 24 kg respectively, taking G equals to 6.67 times 10 raised to power 11 Newton meter squared per kilogram squared. Solution. Force is equals to capital G small m1 times small m2 all over small d squared, where m1, m2 are masses of two spheres respectively, and the d is the distance between the two masses. Force is equals to 6.67 times 10 raised to power 11 times 16 times 24 all over 4 squared, which is equals to 1.6 times 10 raised to power minus 9 Newton. Force of attraction between two spheres is equals to 1.6 times 10 raised to power minus 9 Newton. Electric field. Electric field can be defined as a region in the space where electric force is experienced. Electric force between point charges. An electric force between 2 point charges, Q1 and Q2, is given by F equals to Q1 times cure to all over